This is Isro-Vssc Technical Assistant Electrical Engineering previous year question paper with detailed solution of exam held in 2017. This is a final part. Up to question number 60 we discussed in the last 3 videos. Question number 61. Copper and pure silicon are heated. Which of the following is true? Resistivity of copper increases and silicon decreases is the correct answer. Metals. As the temperature increases, the carrier concentration remains almost the same. But there is a decrease in mobility due to lattice scattering, or the frequency of collision increases and hence resistance also decreases. So that conductivity decreases and resistivity increases, which implies the temperature coefficient of resistivity for metal is positive. Semiconductors. As the temperature increases, the carrier concentration increases. This is because of extra electrons are excited from valence band to conduction band, due to which a number of free electrons increases, so that conductivity increases and resistivity decreases, which implies the temperature coefficient of resistivity is negative for intrinsic semiconductors. The dominant factor is the number of free electrons and hence specific resistance of semiconductor decreases with increasing temperature. The difference in the variation of resistance with the temperature in a metal and a semiconductor arises essentially due to the difference in the variation of the number of charge carriers with the temperature. When copper and pure silicon is heated, the resistivity of copper increases due to positive temperature coefficient and resistivity of pure silicon is decreased due to negative temperature coefficient. That is, copper is metal and pure silicon is a semiconductor. 62. If x equal to 1 in the logic expression, x plus z into y dash plus z dash plus x y dash into x dash plus z dash into x plus y equal to 1. The answer is option D, z equal to 0. Let f equal to x plus z into y dash into z dash plus x y dash into x dash plus z dash into x plus y. As x equal to 1, therefore x equal to 1 and x dash equal to 0. We can write the expression after applying x equal to 1 and x dash equal to 0, f equal to 1 plus z into y dash into z dash plus 1 into y dash into 0 plus z dash into 1 plus y. By using the property 1 plus a equal to 1 and a dash equal to 0, we get f equal to 1 into z dash, which is equal to z dash. We know that z equal to 0, z equal to 1, therefore z dash equal to 0. 63. The drain of an N-channel MOSFET is shorted to the gate so that VDS equal to VGS. The threshold voltage VT of the MOSFET is 1 volt. If the drain current ID is 1 milliampere for VGS equal to 2 volt, then for VGS equal to 3 volt ID is. Answer is option D, 4 milliampere. For an N-channel MOSFET, the current in the triode and saturation region is ID equal to Kn into 2 VDS into VGS minus VTH minus VDS whole square when VDS less than VGS minus VTH, and ID equal to Kn into VGS minus VTH whole square when VDS is greater than VGS minus VTH, where VDS is the drain to source voltage, VGS is the gate to source voltage, VTH is the threshold voltage, and Kn is the conduction parameter. In this question they given the drain and gate terminals are shorted, that is VDS equal to VGS. Since VDS is greater than VGS minus VTH, the device is in saturation. When VDD equal to 2 volt, then VGS equal to VDS equal to 2 volt. From the current equation of saturation, we can substitute ID equal to 1 milliampere, which is equal to Kn into VGS minus VTH whole square. We can also substitute the values of VGS and VTH. We get 1 milliampere equal to Kn into 2 minus 1 whole square. From here we can derive the value for Kn equal to 1 milliampere per volt square. When VDD equal to 3 volt, then VGS equal to 3 volt. Substitute these values in the equation of saturation current ID. That is ID equal to Kn into VGS minus VTH whole square. Here we know the value of Kn, VGS and VTH. Substituting those in this equation, we get ID equal to 4 milliampere. 64. In the circuit of the ideal op-amp, V0 is, answer is option D, plus 15 volt. Here op-amp is inverted grounded. Output is corresponding to the non-inverter terminal, that is V equal to plus VCC, that is 15 volt. Now applying KCL at the node V, we get I1 equal to I2. I1 equal to 1 minus V divided by 1K, that is 1000, which is equal to V minus V naught by 1000. That is 1 minus V equal to V minus V naught. After solving, we get V naught equal to 29 volt. But output cannot be greater than higher saturation voltage VCC. Therefore, output voltage V0 will be limited to plus 15 volt. For the ideal op-amp circuit shown in figure, V0 is, answer is option C, minus 0.5 volt. By superposition theorem, first the voltage gain of the voltage at the inverting terminal is, that is, first ground the non-inverting terminals and apply input to the inverting terminal. Therefore, V0 by Vf equal to minus Rf by R1 is the equation for voltage gain. That is V01 by Vi equal to minus Rf divided by R1. We know the value of Vi, Rf and R1. After substituting, we get V01 equal to minus 2 volt. Secondly, the voltage gain of the voltage at the non-inverting terminal. That is here, applying input to non-inverting terminal and ground the inverting terminal. We get V0 by Vf equal to 1 plus Rf by R1 is the equation for non-inverting terminal. Also, we need to find the voltage at a V plus. That is V plus equal to 1 volt into 1K divided by 1K plus 1K, that is total resistance. We get V plus as 0.5 volt. Therefore, V02 by Vi equal to 1 plus Rf by R1. Substituting the values of Vi, Rf and R1, we get V02 is equal to 1.5 volt. Then the net output voltage equal to V0 equal to V01 plus V02. That is minus 2 plus 1.5 volt. We get minus 0.5 volt. 66. An 8085 microprocessor based system uses 4K into 8-bit RAM whose starting address is AA00H. The address of the last byte in the RAM is, answer is option C, B9FFH. Specification of RAM equal to 4K into 8-bit. Size of RAM is 2 raised to 2 into 2 raised to 10 into 8-bit, which is equal to 2 raised to 12 into 8-bit. So 12 address lines will be engaged. Remaining is 0. That is, if we add, we get the value as 0FFF. Number of address location is 0FFFH. Starting address is AA00H given in the question. So the final address is AA00H plus 0FFH. We get B9FFH. Question number 67. Two 2's complement numbers having sign bits x and y are added and the sign bit of the result is Z. Then the occurrence of overflow is indicated by the Boolean function. Answer is option C, x bar y bar z plus xy z bar. Let a and b two numbers and s equal to sum. A equal to x is a sign bit up to b1 b0 and b equal to y up to c1 c0, where y is the sign bit of number b. And sum s equal to z into s1 up to s0 and z is a sign bit of sum. Condition of overflow are sum of two positive number gives a negative number, there will be overflow. Sum of two negative number gives a positive number, there will also a overflow. In first condition, a is a positive number, therefore x sign bit equal to 0. And b is a positive number, therefore y equal to 0. And sum is a negative number, which indicates z equal to 1. Therefore, the Boolean function of 1 equal to x bar y bar z. In second condition, a is a negative number, x equal to 1, sign bit equal to 1. And b is negative number, y equal to 1. And sum equal to positive number, z equal to 0. Therefore, Boolean function of 2 equal to x y z bar. Therefore, Boolean function of the whole equation is x bar y bar z plus xy z bar. 68. The cascade amplifier is a multi-stage configuration of answer B, CECB. CECB is cascade connection, CECC is cascade connection, CCCC is Darlington pair, where CE is the common emitter, CC is the common collector, CB is the common base. The voltage gain of amplifier can be increased by using cascading connection of individual stages. The cascade connection is used to obtain large output impedance. Darlington connection is used to obtain high current gain. In a cascade connection, the overall gain is equal to product of gains of individual amplifiers. In cascaded connection, overall gain increases, hence bandwidth decreases. Decreasing in bandwidth results increase in lower cutoff frequency and decrease in upper cutoff frequency. For n amplifiers in cascade connection, the overall bandwidth will be fh into root of 2 raised to 1 by n minus 1. 69. Each transistor in the Darlington pair has HFE equal to 100. The overall HFE of the composite transistor, neglecting the leakage current, is answer is option D, 10200. Given amplification factor HFE, which is equal to beta equal to 100. Overall HFE equation is beta into 1 plus beta. By heart this equation, substituting the value of beta in this equation, we get overall HFE as 10200. Question number 70. A 6-bit ladder digital to analog converter has a maximum output of 10 volt. The output for input 101001 is approximately, answer is option B, 6.5. Given n equal to 6. Digital input is 101001. Maximum or full scale voltage V net equal to 10. Therefore, resolution will be, the equation for resolution R equal to V net divided by 2 raised to n minus 1. Substituting the values of V net and n, we get resolution as 0.1587. Since the decimal equivalent of 101001 is 41, so output voltage V0 equal to resolution into decimal equivalent of binary input. This is the equation. By heart this equation. Substituting the values of resolution and decimal equivalent of binary input, we get output voltage V0 is 6.5 volt. Note: if the reference voltage is given, then resolution is V reference divided by 2 raised to n. Question number 71. Maximum conversion time in clock cycles for 3 types of 8-bit ADCs. First one successive approximation, second one dual slope, and third one is parallel comparator are respectively. Answer is option A, 8, 5, 1, 2 and 1. Given n equal to 8, maximum conversion time in clock cycles of 8-bit successive approximate type ADC is equal to n, which is equal to 8. Maximum conversion time in clock cycle of 8-bit dual slope type ADC is 2 raised to n plus 1. Substitute the values of n, we get 2 raised to 8 plus 1, which is equal to 2 raised to 9, which is 512. Maximum conversion time in clock cycle of 8-bit parallel or flash comparator is 1. The conversion time of different type of n-bit ADC. For counter type, number of clocks is 2 raised to n minus 1 and time is 2 raised to n minus 1 into t clock. For successive approximation type, number of clocks is n and time is n into t clock. For flash or parallel comparators, number of clock is 1. Time is t clock. For dual slope ADC, number of clock is 2 raised to n plus 1. Time is 2 raised to n plus 1 into t clock. Note: dual slope is the slowest ADC and the flash type is the fastest ADC. The conversion time of flash type is independent of the number of bits. 72. The logic function implemented by the multiplexer circuit below is ground implies a logic 0. Answer is option D, F equal to XOR of P, Q. Just consider what is 4 into 1 mux. This is 4 into 1 mux has 2 selection lines, S1 and S0. Output is Y. Data lines is I0, I1, I2 and I3. If selection line S1 and S0 has 0, 0 input, the output we get at Y equal to I0. Similarly, for 0, 1 input we get I1. For 1, 0 input we get output I2. For 1, 1 we get output I3. Therefore, the equation for output Y equal to S1 bar S0 bar into I0 plus S1 bar S0 I1 plus S1 S0 bar I2 plus S1 S2 I3. Just come to our question. Here the input get at I0 is equal to 0. And for I1 and I2 it is 1. For I3 it is 0. P is S1 and Q equal to S0. Now the output of 4 into 1 mux is F equal to P bar Q bar into I0 plus P bar Q into I1 plus P bar Q into I2 plus PQ into I3. Here substitute the values of I0, I1, I2 and I3. We get P bar Q bar into 0 plus P bar Q into 1 plus PQ bar into 1 plus PQ into 0. That we get P bar Q plus PQ bar, which is the expression of XOR gate P XOR Q. Therefore, function is XOR of P comma Q. Question number 73. In the circuit shown below, the knee current of an ideal Zener diode is 10 mA. To maintain 5 voltage across RL, minimum value of RL in ohms is. Answer is option A 125. I equal to IZ plus I load, where I equal to 10 minus 5 divided by 100, which is equal to IZ minimum plus IL maximum. We get 50 mA equal to 10 mA plus IL max. After rearranging, we get IL max equal to 40 mA, which is also equal to the other equation for IL max equal to Vz divided by RL minimum. After rearranging, we get RL minimum equal to 5 divided by 40 into 10 raised to minus 3, which we will get RL minimum as 125 ohm. Question number 74. The ALU of a microprocessor performs operation of 8-bit 2's complement of operands. What happens when the operation 7AH minus A2H is performed? Answer is option B. Result is D8H and negative flag is set. Given numbers are A equal to 7AH. Equivalent binary number is 0111 1010 and the given number B is A2H. The equivalent binary number is 10100010. We need to find the result of A minus B. A minus B equal to A plus minus B, which is equal to A plus 2's complement of B. 2's complement of B means 1's complement of B plus 1. That we get 2's complement as 0, 1, 0, 1, 1, 1, 1, 0. Therefore, A minus B equal to 0, 1, 1, 1, 1, 0, 1, 0 plus 0, 1, 0, 1, 1, 1, 1, 0. We get answer as 1, 1, 0, 1 and 1, 0, 0 of binary number. Corresponding hexadecimal is D8H. As the MSB is 1, the result is negative and hence the negative flag is set. As there is no carry involved in the result, the carry bit is 0, that is there is no overflow. There is an 8-bit flag register out of which 5 bits, not nits, bits are used. That is D0, D1, D2, D3, D4, D5, D6, D7. Here D1, D3, D5 are not using. It is reserved for future use. D0 is carry flag, D2 is parity flag, D4 is auxiliary carry flag, D6 is 0 flag and D7 is sign flag. Sign flag. It is set to 1 if bit D7 of the result is 1. Otherwise reset. D7 is the first digit of a binary number. 0 set. When an arithmetic operation results in 0, the flip-flop called the 0 flag, which is set to 1. Auxiliary carry flag AC. In arithmetic operation, when a carry is generated by digit D3 and passed to digit D4, the auxiliary carry flag is set. Generally, this flag is used internally for binary coded decimals, that is BCD. Parity P. If the result has an even number of ones, the flag is set to 1. For an odd number of ones, the flag is reset. Carry CY. After the addition of two numbers, if the sum in the accumulator is larger than 8 bits, then the flip-flop uses to indicate a carry called the carry flag, which is set to 1. 75. Second derivative of sin x with respect to x is, answer is option C minus sin x. Y equal to sin x. dy by dx equal to d by dx of sin x equal to cos x. Now second derivative of sin x with respect to x is d square y by dx square. That is d by dx of cos x equal to minus sin x. 76. In an equilateral triangle, the measurement of the largest angle is, answer is option C 60 degree. A triangle is a closed plane figure having 3 sides and 3 angles. The sum of the interior angles is always 180 degree. An equilateral triangle is a triangle having all the 3 sides are equal. Also all the 3 angles are equal, that is 60 degree. Hence its largest angle is 60 degree. An isosceles triangle has 2 of its sides equal. The angles opposite to the 2 equal sides are also equal. An acute angle triangle is one in which all the 3 angles are less than 90 degree. An obtuse angled triangle has one of the angles as more than 90 degree. A right angle triangle is the one in which one of the angle is equal to 90 degree, that is right angle. The side opposite to right angle is called hypotenuse. The value of x if determinant of x 3, 5, 2x equal to determinant of 5 minus 4, 5, 3 is. Answer is option A, 5, minus 5. Expanding the determinants, 2x square minus 15 equal to 15 minus 20. 2x square minus 15 equal to 15 plus 20. After rearranging, we get x square equal to 25. Therefore, x equal to plus or minus 5. Question number 78. Find the slope of the curve y equal to x cube at 1, 1. Answer is option A, 3. Given y equal to x cube, and now the slope of the curve is m equal to dy by dx, that is differentiate y with respect to x, which is equal to 3x square. Hence, slope of the curve y equal to x cube at 1, minus 1 is m equal to 3 into 1 square, which is equal to 3. 79. If x equal to a cos cube t and y equal to a sin cube t, then dy by dx is. Answer is option B, minus tan t. Given x equal to a cos cube t and y equal to a sin cube t, dx by dt equal to 3a cos square t into minus sin t, which is equal to minus 3a cos square t into sin t. Dy by dx equal to 3a into sin square t into cos t. Therefore, dy by dx, which is equal to dy by dt divided by dx by dt, we get 3a sin square t into cos t divided by minus 3a cos square t sin t, we get minus tan t. The last question of this part and this video is 80th one. LCM of two number is 48 and HCF is 6. One of the number is 24, then the other number is. Answer is option 12. Given first number is 24, LCM of two number is 48 and HCF of two number is 6. We know that first number into second number equal to HCF into LCM. Therefore, second number equal to HCF into LCM divided by first number. Substituting the value of HCF, LCM and first number, we get second number as 12. Thank you.